Hello everyone, welcome to Dr. Ravi's Academy. I am Dr. Ravi, Professor of Mechanical Engineering. In today's lecture, you will be understanding the concept of principal stresses and you are going to derive an expression for principal stress. For that purpose, let us consider a rectangular element subjected to biaxial stresses, stress along the x direction, that is sigma x, and along the y direction, that is sigma y, and you have shear stress also, that is the tau xy. Tau xy, and we are interested in, let us assume that this is element is ABCD, and we are interested in, this is your D and E at an angle. Your DE is a plane at an angle phi with the vertical line CD, and we want to recall the expression what we have derived in previous lecture, that is expression for sigma as well as tau. Let us recall that expression. Sigma is equals to, it is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 phi plus tau xy sin 2 phi. This is the normal stress on plane ED, and we know we have derived expression for tau also, that is tangential stress or shear stress, that is sigma x minus sigma y by 2 into sin 2 phi minus tau xy, it is cos 2 phi. So, let us call this is equation 1 and this is 2, and let us define what is meant by principal plane. A plane on which the tangential or shear stress is 0 is called a principal plane, and the normal stress on principal plane is called principal stress. That means on this particular plane, that is ED, that is tau, so this must be equal to 0. The moment you substitute tau is 0, you are going to get a condition for principal plane, and that condition if you substitute into the equation 1, that is normal stress equation, you are going to get the principal stresses. Now, let us make it 0, and you have sigma x minus sigma y by 2 into sin 2 phi is equals to, it is tau xy cos 2 phi, and you can write down this as it is tan 2 phi is equals to tau xy divided by sigma x minus sigma y by 2. So, this condition you substitute into sigma equation, so that you are going to get the principal stress, and for that you need to write expression for cos 2 phi as well as sin 2 phi. Now, I am writing this as, let us take this angle is 2 phi and opposite is tau xy, and adjacent is sigma x minus sigma y by 2. So, this is applicable if you take both the negative values also. Let us take both the negative values, and this angle, let us treat that it is 2 phi. So, this is minus tau xy, and this is minus of sigma x minus sigma y by 2, and calculate the hypotenuse, that is sigma x minus sigma y by 2 whole square plus tau xy whole square under root. Similarly, here also the same expression which is valid here. Now, you can substitute the value of cos 2 phi and sin 2 phi into this equation, then your sigma becomes sigma 1 the moment you substitute principal stress, major principal stress, it is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 phi is, cos is adjacent side by hypotenuse. So, that becomes sigma x minus sigma y by 2, and hypotenuse is it is sigma x minus sigma y by 2 whole square plus tau xy whole square under root. This is the value of the cos 2 phi plus tau xy, your sin 2 phi, sin is opposite side, that is tau xy divided by your hypotenuse, that is sigma x minus sigma y by 2 whole square plus tau xy whole square. Observe carefully, you can see that it is in the form of sigma x minus sigma y by 2 whole square plus tau xy whole square. It is in the form of this, the leftover term you can write down, it is sigma x plus sigma y by 2 plus the leftover term becomes, it is sigma x minus sigma y by 2 whole square plus tau xy whole square under root. And this is your sigma 1 major principal stress. If we take the negative values minus tau xy as well as minus sigma x minus sigma y by 2 value, you are going to get a negative sign, and that is your minor principal stress. So let us observe carefully the principal stresses. Major and minor is sigma 1 and sigma 2 is nothing but it is sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 whole square plus tau xy whole square. With this you can calculate the principal stresses on any plane. Thank you.